Hi there to you all, and welcome to the Guyana Space Center in Kourou for the main event of the evening. Ariane Space Flight 123, our 7th launch of 1999, carrying the GE-4 spacecraft for GE American, using the Ariane 44 LP launcher ready out there on the pad, and filling your screen as you join us.
Nous sommes ensemble pour un peu plus d'une heure. Ce soir, le commentaire en anglais sera assuré par Simon Heiss. Bonsoir Simon.
Hi Valerie. French commentary is by Valérie Hurtel, and each of us has a technical consultant, in my case, Bart Eilertsen. Hi, Bart.
Hi, Simon.
Et en français, ce sera Patrice Larcher qui sera ce soir notre spécialiste et qui nous dira tout sur le lanceur. Bonsoir Patrice.
Bonsoir.
On se retrouve dans une petite minute, juste après le sommaire.
And a quick look at the rest of the program straight away. We shall meet our customer for Flight 123, GE American, and take a look at the preparation campaign for our passenger, GE-4. Then some highlights of the preparation process for the Ariane 44 LP launcher, before moving on to some footage on the new Ariane 5 launcher in anticipation of the upcoming 504 flight. A piece on the core element of our business, launch service contracts, and all the time keeping tabs on what's going on in the Launch Control Center and Mission Control at regular intervals, before following the flight phase through to injection of the GE-4 spacecraft into transfer orbit. Now you've seen what we all look like and what we're going to show you. This is where the story really begins. So a status report, please, Board.
Simon, we are approaching the end of the final countdown, running now for over 14 hours. All systems are go. All launch authorization parameters on the status panel are green, as we can see. We have a window of 1 hour and 16 minutes for this launch, and it's looking good for liftoff in 27 minutes from now.
Thank you, Board. And greetings to viewers at the observation sites here in French Guiana, all of you in the Jupiter building, viewers in France, Washington, D.C. and Tokyo, our faithful viewing public taking the Space Night program in Germany, and of course a big hi to all you folk at the GE American functions at Disney World Orlando, Florida, in particular Andreas Georgiou, and in Princeton, New Jersey. You've joined us in Mission Control, and we're now going to have a really close look at the launcher. The payload for this flight, the GE-4 spacecraft, has a liftoff mass of nearly 4 metric tons, and the Ariane 44 LP version with 2 liquid propellant and 2 solid propellant boosters is being used for this mission.
The first stage has 4 Viking engines burning propellant at a rate of 2 tons per second. The second stage is smaller, lighter, and has 1 Viking engine. The first and second stages represent the power pack used to break free from the gravitational pull of the Earth. The third stage burns liquid oxygen and liquid hydrogen and provides the additional acceleration required for satellization velocity at 9.7 kilometers per second or 35,000 kilometers per hour, or for our American viewers, about 22,000 miles per hour. The launcher stands 56 meters tall and is topped off by the fairing. This protects the payload during the atmospheric flight phase.
And GE-4 will be placed into geostationary transfer orbit in a little over 20 minutes after liftoff. So let's see what that all means, Board.
Well, we shall see that the object of this exercise is to loft the payload to an altitude of 215 kilometers, the low point on the orbit, and place the satellite into its geostationary transfer orbit. This corresponds to the green segment in the diagram on the screen right now, and we shall see this diagram again later in the program. The trajectory is in a quasi-equatorial plane close to that of the final geostationary orbit of the spacecraft, and the geographical position of the Kourou range at 5 degrees north is a big advantage in this respect. After separation, G4 will use its own apogee kick motor to circularize its orbit and get on station at 101 degrees west over the Galapagos Islands.
And we've just had a satisfactory last but one pre-launch weather report. The satellite is snug down inside the fairing in a controlled environment, temperature, humidity and pressure, and it's monitored permanently from the Launch Control Center. So down the 1 kilometer double rail track and in at the door.
Look at this door and its thickness. This is the entrance door to the Launch Control Center. It is heavily armored and 30 centimeters thick. We are here only 1 kilometer from the launch pad. That is why the building is protected, not only by this huge door, but also by walls 1 meter thick. During countdown and liftoff, the Launch Control Center houses a team of around 100, coordinated by the COEL.
I'd now like you to meet the Ariane Launch Site Operations Manager, the COEL, for Flight 123, Yves Bondil. Yves heads a team of specialists who supervise and cross-check the launcher and the complete launch system, the launch table, the umbilical tower, the gantry, the fueling system and so on, right through to liftoff. And back to mission control. Do you caress doors too, Baud? Where we'd like you to meet with 2 more introductions.
First of all, Bernard Purenier, the Arianespace Mission Director for Flight 123. Bernard supervises the launch operations throughout the launch campaign. And to his side, we should see the Range Operations Manager, the DDO, Pierre Ribardière. The DDO coordinates all activities on the launch base. Immediately after liftoff, the DDO will start feeding us with a stream of information on the launcher status. This information naturally comes from the 44LP itself. We'll explain how at the right time.
Taking a time check, less than 23 minutes to the start of our launch window, with all status indicators on green. It's looking good for a punctual liftoff. We're now going to see and hear something about our customer, GE Americom, and the satellite system to which GE-4 will be the latest addition.
For close to 20 years, one company has made available the full range of satellite communications you see, hear, and use every day. Sounds, images, and information all around you have been beamed 23,000 miles into space and returned to their target audiences by a GE Americom satellite.
9, 8, 7, 6, 5, 4, 3,
Ariane space flight 113 is off the ground with every star and GE-4.
Accelerating normally. We're now 2 nautical miles in altitude.
We are no longer earthbound, but are travelers in the frontier of space. Our own man-made vehicles now sweep above us, held in orbit as mirrors for our ideas, our voices, and our images. These sophisticated packages of engineering wizardry compose one of the world's largest fleet of communication satellites operated by a single company, GE Americom. Their presence is transparent to us. News services speak, people listen. Businesses send massive data streams. Enterprise operations receive them. Television broadcasters fill the communication spectrum with images, sounds, and events of our world, and audiences experience them. Receiving and beaming back, receiving and beaming back. Over 300 GE Americom satellite transponders operate tirelessly and efficiently in a vast arc in space above the equator. Antenna arrays project digital terabytes of information to Americom satellites. And 1,000 or tens of thousands of miles away, an audience is informed. A computer updated. Students learn. Since the pioneer days of 1975, Americom has been a leader in this technology. broadcasters, newspaper publishers, radio networks, government agencies, business and industry, as well as those probing the secrets of our solar system, rely on this satellite fleet. Our audience is becoming a global legion, bonded together by the fulfillment of their need to know, to understand, and to reach out. We at GE Americom are committed, by our legacy of excellence and technological innovation, to reinforce that bond with satellites that serve us and connect the peoples of our planet.
Well, before we move to a rundown of the satellite preparation campaign for GE-4, and having checked that the launch is still out there on the pad, we have the chance to meet some of the GE-4 team.
Walter Brown is GE Americom's Senior Vice President Engineering. He is next to Véronique Séguin, the Ariane Space Mission Manager for the GE-4 contract and this launch. And represented Lockheed Martin, which built the spacecraft for GE Americom, Dan Crowley, Vice President Space Systems.
The GE-4 spacecraft on October 21st. It was then transferred to the preparation building, where the activities immediately began. The particularity of this program is its short duration. In fact, the launch contract was signed on the 29th of July this year, in other words, only 3.5 months ago. That is why the launch campaign has to be as short as possible. The teams had to work 7 days a week, 3 shifts per day. As a result, this campaign is the shortest ever done by Lockheed Martin in French Guiana. After its transfer to the fueling building, GE-4, the first Lockheed Martin A2100AX ever launched by Ariane, is integrated on its adapter. The fairing, which will protect the satellite during the atmospheric flight, is installed. The composite is transported to the launch pad and is hoisted up to the payload platform at a height of 60 meters on top of the launcher.
Preparation of the Ariane 44LP for this, the 122nd Ariane flight, that's not an error, took a total of 26 working days, and we now have a film summary of the campaign.
Our launcher for tonight's flight arrived by boat from Europe, as do all our launchers, and was transported by a road convoy to the facility here at the base. The first stage is the first element to be erected directly onto the launch pad, the movable launch pad. It's rail transported. Then logically the second stage is hoisted onto the top of that the day after. You see the nozzle of the engine there.
What are those colored ribbons hanging around there for?
They are ribbons marking remove before flight items, just to be sure that you remember to get them away before you leave. Following the second stage integration, we then integrate the liquid strap-on boosters, the PALs. And then it's time for the third cryogenic stage to be integrated with its slightly brownish thermal insulation cladding. And the last element to be hoisted on top of all this is the vehicle equipment bay containing all the launcher electronics. At this point, the whole assembly is moved out the 1 kilometer stretch to the launch pad, where the cryogenic fueling arms are attached to the third stage, and the movable gantry is moved around the launcher.
Everything is still strictly nominal, so the members of the Flight Command Cell here in Mission Control, headed by Jacques Rossignol, Ariane's first Chief Operating Officer, have only to wait and watch. They only become directly involved in the proceedings if a major decision, such as whether to stop the count or go for launch, is necessary. With Ariane 5 almost on the starting blocks for Flight 504, we have some film of the new launcher.
Versatile, flexible, powerful.
Attention pour le début de la séquence synchronisée, top moins 7 minutes. Donc les H0 moins 3 minutes, correct.
Déroulement correct.
À tous du DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage Vulcain. Allumage ERP. Décollage. Propulsion normale. Tous les paramètres sont normaux à bord. Trajectoire normale.
All okay on board.
Ready to serve your business.
"11 minutes to scheduled liftoff, and we are green." Something that naturally concerns both Ariane 4 and Ariane 5 alike is the signature and processing of launch service contracts. We have a short clip on this subject with Véronique Segal. "206 launch contracts so far. Arianespace strength lies in its worldwide presence. A good example, the recent Telecom 99 event in Geneva. Arianespace know-how means exhaustive understanding of customer needs and the supply of tailor-made launch services. The company adopts an original approach in this regard. The customer has a single contact up to signature of the contract, the sales manager, who then hands over to the mission manager for the entire period through to launch.
Once the contract has been signed, the mission manager takes over. He or she is responsible for all technical and financial aspects, fixing the launch date, finalizing launcher configuration, in a word, everything relating to the launch contract. In technical terms, we have to ensure that the satellite involved is fully compatible with Ariane 4 and Ariane 5. I love my work. It gives me an overall view of Arianespace activities, both in-house, as I am in permanent contact with all divisions of the company, and outside, as it gives me also a worldwide horizon.
So today let me introduce you Dennis. Dennis is here for GE-4.
Dennis, what do you think of your job?
Well, basically, my job's the same as yours, Veronique, except that I have to coordinate data from the spacecraft manufacturer and make sure that data flows in both directions. Other than that, it's the same. It's from the contract signing all the way to launch.
Okay, thank you, Dennis.
You're welcome.
We'll come back to the subject of launch contract processing a little later on board. Very much your province, I think.
It is indeed, Simon. Yeah, I'll be only too happy to do that.
Well, while we watched that clip, you were listening to the final T-minus 10 minutes weather report. How do we stand there?
It's green, 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 and green. All the meteo parameters are green for the entire length of the launch window tonight.
Well, that sounds pretty reassuring. But what, in fact, are the main weather constraints we have to cope with?
Storm activity and wind, basically. Coming up now, news of recent and current events in the Ariane calendar.
Liftoff of Flight 122 on 19th October with Ariane 2 for Laurel Orion, another long-standing Ariane customer. News of the satellite is excellent, as was launch accuracy. Preparation of the XMM multi-mirror laboratory payload continues apace, with launch on Ariane 5 Flight 504 scheduled for the first half of December. Now some shots of enhancement work on the flame shoots of the ELA-3 pad, which will be used for Flight 504. And finally, liftoff of the 5th Starsem-Soyuz launch from the Baikonur pad, with another 4 satellites for the Global Star Constellation project. Not much more than 7.5 minutes to go as we return to real time. And we should have a satellite weather picture of the Kourou zone coming up any moment. I hope this doesn't contradict the weather data we've just had, Board.
It shouldn't do, Simon. It dates back a little bit in time, but that's one of the elements that have been used to produce the weather forecast. So
good. So we have no trouble either with high altitude wind on this occasion?
Absolutely none.
This has been troublesome in the past. We're getting close to the end of a count in process for over 14 hours. Why, in fact, does the count last so long, Board?
Well, it's mainly a question not so much of precise timing, though that is essential towards the end of the count, but of ensuring that each one of a series of tasks is executed and in the right order. As regards timing, a number of margins are effectively built into the count, such that if we ever had a small problem, it would be transparent to the start of the launch window. So effectively, don't worry, Simon, the tanks have all been filled, the bolts have been tightened, and they've even remembered to put a space scaffold on top of the launcher.
What a splendid idea. Well, the final segment of the count is coming up, and we're going to have a complete switchover in the launcher control situation. This will occur 6 minutes before time T, first stage ignition, when we enter the synchronized sequence. Explanations when we get there. The DDO will give us the time check.
Attention pour le début de la séquence synchronisée.
And our status panel is the color of a nice, freshly picked Granny Smith.
Top, moins 6 minutes, début de la séquence synchronisée.
Well, we're inside the synchronized sequence and counting, and control of the launcher has been taken out of the hands of the human operators in the Launch Control Center and handed over to 2 powerful ground computers. This is the occasion for relief on the part of the CDL personnel, and the reason is quite clear. During this final phase of the count, there's such a huge increase in the mass of data to be collected, sorted, processed, and above all checked, and the number of command signals to be generated and transmitted is so great that the situation could not be handled in any other way in so short a time. So let's see what actually happens.
Well, the control function is switched to the 2 computers. Each one of them has its own specific set of tasks, and all the resources used in the launch system are synchronized on a common final countdown sequence, which explains the name, by the way. Coming back to our computers, one places the fluid and propellant systems in flight configuration.
And breaking in here, if you'll excuse me, Board, we have our last piece of film, which was shot only 6 hours back. The gantry protects mentioned personnel and provides access to all levels for final preparation tasks during integration of the payload composite in particular. When this work has been completed, it takes in real time, not the few seconds you'll see in this clip, but a full hour to shift this huge structure, 98 meters high and weighing almost 4,000 tons, a distance of only 80 meters. With the gantry withdrawn and all personnel pulled back from the pad, third stage fueling with liquid hydrogen and liquid oxygen can commence. The very low temperature of these propellants, minus 250 degrees Celsius, requires preliminary chilling of the fueling circuits and valves. And in this state, of course, Ariane is secured and stabilized only by the launch table clamps and the cryogenic arms. Back to you, Board.
Well, to come back to our computers, one places the fluid and propellant systems in flight configuration and performs the corresponding checkout routines, and the other carries out similar tasks for preparation of the electrical systems. These include the flight program, startup of the servo motors, switchover from ground to onboard power, and so on. The computers also jealously cross-check each other, by the way.
Well, with the computers in charge, you may think that Yves Bondil and his team in the Launch Control Center, here we see them again, have nothing left to do and can sit back and relax. Well, wrong, and wrong again. They still have a key monitoring task and, in an extreme case, of course, a control override function. And as for relaxing, well...
Not likely.
No.
We might also say that a similar monitoring function is provided by the project room at Ariane Space headquarters near Paris, France. The project room is a sort of a miniature CDL, staffed by experts who monitor the status of everything in the real CDL and on the launch site, and who can supply specific advice in case of need.
So they're obviously in constant and permanent telecommunication contact with the mission control and the CDL.
That's correct.
And if we have a red state come up for any reason inside the synchronized sequence, the count goes back to minus 6 minutes and is stopped. The launcher is returned to the safety state and we go on hold. But we don't need to talk about that unless we get a red. What we will talk about in a few moments are the cryogenic arms, the cryogenic fueling arms, which, as we said earlier, are, here we see them in camera at the top of the tower, and we shall see a first close-up of one of these arms before we zoom in. Here we are.
After this close-up, we're going to zoom in on the fueling arms and still coupled to the third stage valve placement seen from the launch tower. Their fueling task has been completed, but the arms continue to provide a stabilizing function after gantry withdrawal. The two cameras produce a squashed launcher third stage effect, as we shall see when they move together like that. And we shall see this picture again when the arms open 5 seconds before first stage ignition.
Well, we're a little more than a minute and a half to go from liftoff. Tension mounts in mission control, the CDL, the tracking and telemetry stations, all of which are, of course, on full alert, and indeed here in the commentary boxes. The launch is ready. The satellite passenger is surfing on the net to fill in time. The status panel is still green for go. We have a reasonable window, but hands are getting just a little bit fidgety now.
À tous de l'EDO, attention pour le passage à H-1 minute.
We come to the last 60 seconds of negative count.
Top, moins 1 minute.
We're inside the last minute. The launcher is on onboard power. To the GE-4 teams, wherever you are, good luck, good launch, good orbit, and good luck, Mr. G. The main servo motors are armed. The inertial guidance gyros will be released at minus 9 seconds, and the cryogenic arms will open, as we said, at minus 5 seconds. First stage ignition will occur at time T. The solid boosters are ignited, the launch table clamps open, and Ariane lifts off at plus 4.4 seconds.
À tous de l'EDO, attention pour le décompte final.
And we'll leave it to the DDO.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage.
We have ignition. We have liftoff.
Décollage. Tous les paramètres à bord sont normaux.
All parameters on board are normal. First message.
We We've had our first announcement from the DDO, but we'll let you enjoy the spectacle.
Tous les paramètres bord
We
sont
have a clear sky for this episode.
Extinction des propulseurs à ergol solide.
We have the burnout of the solid propellant boosters. And we're 1 minute into mission. Still a beautiful clear picture from the launch site tracking cameras.
Largage des propulseurs à ergol solide.
The solid propellant boosters have been jettisoned, and you can probably hear the rumble of Ariane just overhead of the Jupiter building at this moment. Still a wonderfully clear picture.
Tous les paramètres bord sont normaux.
And we continue to have reassuring announcements from the DDO concerning the strictly nominal situation with all onboard data. We'll tell you how he gets this information in a little while.
Tous les paramètres bord sont normaux et la trajectoire est normale.
Everything continues strictly nominal. And we're now over 2 minutes into mission. And we can give you a status check. We have
Extinction des deux propulseurs d'appoint à ergol liquide.
The two liquid boosters
Largage des
just,
deux pales.
burnt out, and they have been released, as you see on the synthesized image in the upper right-hand corner.
You said it for me, Board. The altitude is now approaching 50 kilometers. Our speed is nearly 2 kilometers per second. And we are, at this moment, almost 3 minutes into mission.
The next major event of the flight will be the separation between the first and second stages, which you see on the curve on the left-hand side.
Tous les paramètres bord
SEP12,
sont
which is the
normaux et la
separation point.
trajectoire est normale.
In fact, I think this is the moment to describe Walter Brown looking fairly relaxed, top left. This is the moment to explain in some more detail the trajectory display that we have steadily on our screen.
On the left-hand side is the trajectory at every instant. The round circle is the spot where the launcher should be according to the pre-launch analysis. And inside it
Extinction
is
du
a small
premier
cross,
étage.
We
which
have
represents
burnout of stage 1,
Séparation du premier étage.
separation stages 1
À
and 2.
l'image du
Of course, the numbers we have on the right-hand side, I mean, you already mentioned them, Simon, but the A stands for altitude and V is velocity.
We're heading for a target of 9.7 kilometers per second at orbit injection, and that corresponds to 35,000 kilometers per second, or roughly 22,000 miles per hour.
We are now coming up to the point where we'll separate the fairing, which has been protecting the spacecraft from the environment so far. But since we are now at an altitude of about 100 kilometers, there's not much air to protect it against.
Right, and the objective is always to drop off surplus mass
largage de la coiffe.
at the very earliest possible moment, and we have confirmation of fairing jettison.
There is Mark Pasquale, the GE-4 program manager at Lockheed Martin. Mark asked me, as a matter of fact, to extend his thanks to his team here in Kourou, as well as those in Sunnyvale, California, and in Newton, Pennsylvania, for their efforts in making the GE-4 program a success. And he would also like to say a special hello to his sons Michael and Justin, who are watching the launch in Sunnyvale.
Well, I'm glad you got that in, Bod, so I didn't have to remind you.
To his side, by the way, is Danny Harrell, the GE Americom program manager.
And we're now 5.5 minutes into mission, and we're approaching a key point in the flight path, separation of the second and third stages.
Extinction du deuxième étage.
Burnout of stage
Séparation
2.
du deuxième étage.
Separation.
Allumage du troisième étage.
And the OOF, the big one,
Third stage is up and running.
Third stage.
And it will be running for a long time, Simon.
Yes, we have a long
Tous les paramètres bord sont normaux et la trajectoire est normale.
burn time exceeding 12 minutes with the third stage. The third stage, remember, is cryogenic, burning liquid oxygen, liquid hydrogen. And a process that has been going on since liftoff is the chill down of the circuits, which feed the propellants into the combustion chamber of the third stage. Well, as we said just a moment ago, we have a long burn time now, and it gives us the...
Acquisition par la station de Natal au Brésil.
We have acquisition of the launcher by the Natal tracking station in Brazil, taking over in due course from the local stations here in Guyana. And as we settle into the long third stage burn time, on-board data still nominal, we have the opportunity to say some more about our customer on this flight, GE Americom, one with which Ariane has been associated since its very first launch contract and launch. Can you sketch out the long-standing relationship for us a bit, Bård?
Well, first of all, I think it merits mention that GE Americom is one of the oldest space commercial companies around. They started their operations in 1973. They own one of the largest spacecraft fleets in the world. They operate 11 geosynchronous spacecraft at this moment. And the first launch with Ariane was 9 years ago, almost to the day.
So how many satellites have in fact have we launched?
Well, directly for GE Americom it will be 5 with today's launch, GE-4.
And there have in fact been a number of other Ariane-launched spacecraft which GE is also operating. What's the story behind this situation?
They are actually operating a part of the Sirius 2 payload, a spacecraft that we launched for the Swedish Space Corporation, but on which GE Americom use half the capacity for European coverage. It's called a GE-1E in their system. And they are an equity partner in the NOWLSAT, operating over the South Americas.
Right. And perhaps a thumbnail data sheet of the GE-4 spacecraft, capacity, coverage, lifetime and so on?
Well, it's a big bird, 3.9 tons, 7 kilowatts of onboard power. It has 24 C-band transponders and 28 Ku-band transponders. And it provides coverage for basically broadcasting services over North America, Canada, Mexico, Caribbean, and Central and South America.
And how does it compare, for example, with the very first of the long sequence of GE satellites?
Well, the spacecraft that we launched 9 years ago, the first one for them, weighed only 1,200 kilos. It had 24 C-band transponders with a total onboard power capacity of about 1 kilowatt.
Well, that's...
so we've gone forward a bit since then.
I was going to say... Well, that's...
so we've gone forward a bit since then.
I was going to say it's indicative of the technological progress we've had over the last 20 years. And talking of 20 years, just a reminder that this year is the 20th anniversary of the first Ariane launch. Well, we said earlier that launch contracts are the core element of Arianespace activities, and that a key feature of the Arianespace commercial policy is the single contact customer relationship involving a mission manager assigned specifically to each contract. You're now Director of Customer Services and you've had extensive experience yourself as mission manager. And we have loss of signal by the Kourou tracking station.
Which is normal,
so
since we're already in Natal's reach.
Right. So tell us more about it, Bård.
Well, the principle which has been reigning at Arianespace since the beginning has always been to have one single person as the contact between ourselves and the customer. We have a sales manager who handles the relationship up until the signature of a contract. And we have the mission manager, who takes over from that point on until the spacecraft is launched. This provides a very easy interface for the customer because it only has this one person to talk to for all aspects of the contract, be they technical, commercial, or financial.
Surely. So how many mission managers are there under your orders?
Eight mission managers.
Does that include yourself?
No, it doesn't. Although I do try and keep my hands on the contract continuously, just to.
And are they individually assigned to a customer or a contract or both, or how does it?
It's both, as a matter of fact. Yes. It's obvious that if somebody has a standing relationship with a specific customer and it's a good relationship, it's in our interest and in their interest to keep the same person on that contract.
But does this mean that the same mission manager may have to manage 2 or more contracts in parallel?
Well, the mathematics are easy, given that we are now at about 43 spacecraft on our order books and we have 8 mission managers. Well, that's 4 to 5 per person.
Fairly easy mathematical problem then, yes. And how long generally between contract signature and launch?
That is, there's a lot of variation there. I mean, tonight's launch, of course, is an extreme point because this contract was signed 3.5 months ago. So that's about as short as they get.
Breaking in there, Board, I think we might reassure 1 or 2 nervous viewers who may have noticed that the trajectory is dipping. In fact, the launcher is losing altitude, but gaining velocity, and I think this is cause and effect, is it not?
This is a natural consequence of the way the launcher has been designed, and it's an optimization of the trajectory, allowing using the gravity pull, as a matter of fact, to help build velocity.
Right. Well, not only the mission managers we've just been talking about, but we could say the whole of the Ariane community is very busy at the present time. We have a tightly packed schedule. Now the flow of satellite passengers.
Acquisition par la station télémesure de l'île d'Ascension.
And we have acquisition of signal by the Mid-Atlantic Ascension Island tracking station. And talking of a restarted flow of satellites, we might say a word of thanks to Lockheed Martin for on-time delivery of GE-4.
Absolutely.
And we have at the present time 3 launches slated for December. 3 in a month, 3 times 12. Could that mean 36 launches next year, Board? Not a very serious question.
Il reste un peu moins de 6 minutes de propulsion.
And we have just under 6 minutes burn time with the 3rd stage left. But how does the Ariane system cope with the kind of sawtooth satellite availability situation that we've had recently?
Well, to be honest, with some difficulty, of course. It's not easy to rearrange the schedule totally when we have problems like that. But to date, and it's not something new, we've had this kind of problem for the last 2 years, as a matter of fact. And we have, in all cases, managed to launch the spacecraft practically on the day that they were ready. Of course, we now have a very tight program, as you've stated, for the end of this year, with 3 launches in December. This is, of course, not something we can keep up indefinitely. We just heard that the 3rd stage is still functioning nominally.
Perte du lanceur par la station télémesure de Natal.
Loss of signal by the Natal station.
As I said, we are helped doing 3 launches in December is only possible because we are using 2 separate launch systems. It's Ariane 4 and Ariane 5.
Right. Well, adaptability, flexibility, switching launches, revamping the launch manifest, all these are good for keeping everyone on their toes. But smooth, regular, repeated routines are also good. However, in either case, the big question is this. In almost every respect, nothing so resembles an Ariane launch campaign as another Ariane launch campaign. So how are concentration, rigor, strict attention to detail preserved and kept at top level?
Tous les paramètres bord sont normaux et la trajectoire est normale. Il reste 4 minutes de propulsion.
We have 4 minutes left until shutdown on the 3rd stage.
And all onboard data strictly nominal.
Well, to get back to your question, Simon, through a rigorous adherence to procedure, maintaining motivated personnel, I think also that, as you mentioned, the regularity is a major issue here. Launching at very short intervals means that everybody is very up to date all the time on the operations that they have to perform.
So I think on their toes is a fairly apt reflection.
If you've done 48 launches in a row with success, I think you can qualify that as being on your toes.
Yes, well, looks good for this one too at the moment. Ariane 5, we saw some film on Ariane 5 earlier. No one has forgotten the eminently successful 503 demonstration qualification flight.
Tous les paramètres bord sont normaux. Il reste 3 minutes de propulsion.
And we have 3 minutes burn time left with stage 3. And everyone is awaiting the now imminent 504 launch. What's the latest news board there?
504, of course, will carry the European X-ray spacecraft into orbit, the XMM, X-ray multi-mission spacecraft. The spacecraft itself has gone through a totally nominal campaign, and it's at the point now where we will start fueling operations of the spacecraft on Monday next, totally according to plan. The launcher, of course, is itself ready, and since a long time, because it's due to spacecraft problems that you haven't been able to get it off the pads for a long time. The launch itself is planned for the 10th of December.
And looking further ahead, while we have still a little bit of talk time before shutdown of stage 3, what about the ambitious Ariane 5?
Tous les paramètres bord sont normaux. Il reste 2 minutes de propulsion.
Performance enhancement programs. What is the situation there? And we have 2 minutes burn time left with stage 3.
We would like, if we can, to manage 6 Ariane 5 launches next year.
Sounds ambitious.
Well, you have to go for it.
Surely. Surely. So 6 next year, 6 Ariane 5. What about Ariane 4?
The two, of course, are a bit intermingled. I mean, yeah, we have a certain number of spacecraft to loft, so on the Ariane 4 side, you can count on 8 to 9. So although we have the industrial capacity to launch even
surely.
more.
So we're looking at 13, 14, 15 in the year, all being well with satellite availability once again.
It's that again, yes.
Tous les paramètres bord sont normaux.
And we're coming very close to burnout of stage 3.
Il reste 1 minute de propulsion.
1 minute left to go. Nominally.
Right.
One should not be surprised to see a few seconds, give or take.
There is a tolerance then.
Acquisition du lanceur par la station télémesure de Libreville au Gabon.
And we have acquisition by the Libreville tracking station in Gabon.
No, you know, the third stage is the one that does the final thinking, is the one that will burn until it obtains the required orbit.
Il reste 30 secondes de propulsion.
30 seconds, and just time to point out that you will all have noticed that the curve is already going up again, and the altitude figure is climbing, and we're very close to the 9.7 kilometers per second target.
10 secondes. Extinction du troisième étage.
And we have burnout of the third stage, and something just under 2 minutes to go to separation of our payload.
Début de la manœuvre d'orientation du composite.
Would you take us through the spin-up procedure, Bart?
Well, what happens right now is that the third stage will maneuver itself to the attitude required by GE-4 for its separation. That is how it wants to be pointed once it's on its own. And just before it will be pushed off by the separation springs, it will be spun up to a very low spin rate.
Such as?
0.6 RPM. Or thereabouts.
And you will have noticed from the data column on the right of the screen that we hit the figure of 9.7. In fact, we went slightly over. Remember, that's 35,000 kilometers per hour, and already that figure is dropping very slightly.
But the altitude is going up.
Indeed.
It's the law of physics in work here.
Surely.
Fin de la première manœuvre d'orientation.
Completion of the first spin-up.
No, orientation maneuver.
Sorry. Correction. That figure of the peak figure of the apogee, sorry, the perigee figure of 9.7 drops to what by the time we get up to 36,000?
drops to between 1 and 2 kilometers per second.
And then builds up again.
Then builds up again as you go down towards the perigee.
Surely. Anxious moments again for the satellite teams, but we're very, very near to the
Separation GE-4.
And there we are.
There we have the good news. In fact, the computer-assisted display top right of your screen anticipated the event, but why not?
Happy faces.
Yes. Kisses and hugs for our mission manager. Her first solo.
Yeah.
Congratulations for the mission director, and congratulations naturally for our customer.
Of course, this represents only the first and very initial step as far as his spacecraft is concerned, because now starts a long series of operations on the spacecraft itself.
And we can give you a quick rundown of the early autonomous life of the satellite. It should be picked up in about 25 minutes from now by its first downrange tracking station, Guam. It's going to make 5 apogee burns, the first the day after tomorrow, and the 5th and final on the 22nd of October. Solar panels and antenna will be deployed on the same day, and testing should be completed by about the 13th of December, and the satellite on stream just before Christmas, 22nd December. A computer-assisted replay of satellite separation.
Without the spin, though, but still. Or it's very slow on that picture.
And here we have the diagram which we told you about before, demonstrating what has just happened.
So now GE-4 shall climb up to its apogee. It'll do that orbit 4 times before it fires its own engine for the first time on the 4th apogee, as the red arrow shows.
And the apogee burns, of course, are part of the process of circularization of the orbit and the approach to final orbit station. Walter Brown looking even happier than before.
Well, you can't blame him, can you?
No, it's a great moment for, if I might say, all of us.
GE American and Lockheed Martin, they have been pushing very, very hard for this launch. It's been a very difficult few months leading up to this for them.
And in fact, the whole thing has been a very quick operation, has it not? Signature to launch. How long?
3.5 months.
Right, well... and our first replay.
Allumage. Décollage. Tous les paramètres bord sont normaux. Tous les paramètres bord sont normaux et la trajectoire est normale. Extinction des propulseurs